So today we're going to talk about calculating in significant figures, okay, calculations. If you haven't watched part one on significant figures, stop the video and go watch that right now. You need to know what significant figures are first, okay? Now, when you make a measurement that needs to be calculated, for example, area, you need to measure the length, and then you need to measure the width, and then you calculate area by multiplying length times width. So that value there, area, is actually calculated from two measurements. You cannot report that calculated measurement, that calculated value, with a greater degree of accuracy than your measurements. Okay? So there are some rules here about when you calculate what to do. They're different for multiplication and division. So first I'll talk about they're different for multiplication, division, and addition and subtraction. So first I'm going to talk about multiplication and division. All right? So when you multiply or divide two measurements or more, you're going to round your answer to the fewest number of significant figures of the measurement that has the fewest number of significant figures there. Let me give you an example that might make more sense what I mean here. So let's say I was calculating area. All right? I measure the length of my rectangle is 12.50 centimeters. The ruler I used was able to get me to the hundredths place. Okay, so I have 12.50. I think it's right on the line, so I put a 0. And then I measure the width, which is 2.05 centimeters. Okay, hundredths place again, same ruler. Now, area is length times width, so 12.50 centimeters times 2.05 centimeters is 25.625 centimeters squared. That is what my calculator would report to me, a bunch of decimal places. But that looks like I have an accuracy all the way to the thousandth place. 0.625. I mean, the 5 is in the thousandths place. My measurements weren't to the thousandths place. They only went to the hundredths place. So our answer has to kind of reflect our measurements. And it goes by how many significant figures the measurements are that we use to calculate it. So how many significant figures do these measurements have? Let's start with the first one. 12.50 has 4 significant figures. 2.05 has 3 significant figures. Okay, now what we want to do is which of those is worse. Okay, the worst one, that's the one we want to stick with, the lower one. So that one is lower, the 3 significant figures, which means our answer needs to only have 3 significant figures. Okay, your answer will have the same number of significant figures, you have to round it, as whichever measurement had the lowest number of significant figures, in this case 3. So how do I round that to 3 significant figures? We have the 2, I'm going to start on the very end, I'm just going to count. So we have the tens, the ones, and then the tenths place. So I want 3 digits here, so tens, ones, and then I'm going to round it here so that I have a decimal, that's my tenths place. That would get me 3 places, 3 significant figures here. The next number here is a 2, so it rounds down, so I'm going to round it to 25.6 centimeters cubed. 25.6 centimeters cubed. And that has 3 significant figures, same as the 2.05, the lower of the measurements I used to get it. Let's try division here. Let's say I want to calculate density of something. Density is the mass divided by the volume. So I measure the mass as being 45.673 grams, and then I measure the volume as being 6.1 centimeters cubed. You would use completely different devices to measure those two things, because you can't use the same, one for mass, one for volume. So they have different amounts of uncertainty. Now, if I plug this into a calculator, 45.673 divided by 6.1, I would get 7.487377, a whole bunch of decimal places. And density is grams per centimeter cubed. Okay. How should I report this answer? Well, how many significant figures do the measurements have that I used to get it? So this first one here, 45.673, has 5 significant figures. The second one, 6.1, has 2 significant figures. 2 is lower than 5. Okay, so I want to round my answer so that it also has 2 significant figures. because that is the lower of these two. Okay, two significant figures here. So how do I round this so it only has 2? Well, I want to have the 5, there's 1, and then I want to have the 4, there's a second. However, there's an 8 next to the 4. Remember, we're rounding, not just cutting off. So if there's an 8, we want to look at, okay, I want to keep the 4. That's the digit I want to keep, 7 and the 4, two significant figures. But then I look at the next digit, that's an 8, which would round the 4 up to a 5. So I would report this as 7.5 grams per centimeter cubed. Okay? Two significant figures in my answer. Now you try it. Go ahead and pause the video, pull out a calculator, get an answer, and then round that answer appropriately. Okay? Okay, so this is more about the rounding than it is about the math. So I'm just going to throw out what my calculator says here. So those are the answers according to my calculator, which is not what I'm going for here. I want to know about the rounding. So this first one, 2.6 has two significant figures. 3.78 has three significant figures. 2 is lower than 3. So my answer here has to be rounded so it only has 2. That would round to 9.8. 39 divided by 24.2. This number has two significant figures. This number has three significant figures. So the answer, 943.8, I have to round that so it only has two significant figures. Same as this 39 here, not this 24.2, because 2 is less than 3. So round this to two significant figures. I want to keep the 9 and the 4. There's a problem here. It's not 94. It's 940. So don't forget, this 0 here on the end is not significant. It's telling you it's 940. The 4 is the uncertain digit in this measurement. Okay? Not the 0, so this only has two significant figures, but we don't want it to say 94. We want it to be 940. Okay? Now this last one here, 1.25 times 1.4 times 4.0. This has 3, this has 2, this has 3, so our answer should have 2. Well, it only has 1. Both of these we had to round and kind of cut off some of the numbers, but this one only has 1. How do we get 2 out of it? Well, you add a 0. Okay? You actually get more digits here. That happens sometimes, where you actually have to add significant figures. If you have to do that, 0.0. Start adding some zeros there that are significant. Okay? 7.0. All right, so that is multiplication and division. Addition and subtraction. Okay, they have different rules. Addition and subtraction, you are not going to round to the number of significant figures of the lowest. You are going to round your answer to the fewest number of decimal places. Okay, when we are calculating with multiplication and division, since significant figures here, the decimals kind of compound and make lots and lots of decimals, we round to significant figures. But with addition and subtraction, it doesn't compound like that. So we just want to round based on the decimal places itself. All right? So addition here, I'll give an example. I have 1.51 grams plus 2.053 grams. Okay, I was measuring mass, and then later I measured mass again with a different balance, so I was able to get it to the thousandths place instead of just the hundredths place. So I add them together. Calculator says 3.563 grams. How should I report that? Well, I want to look at how many decimal places they have. First one, hundredths place is how many? It's 2 decimal places. Second one goes to the thousandths place. That's 3 decimal places. 2 is less than 3. Go to the whichever one is lower. Okay, so my answer can only have the hundredths place. That would be the 6th here. The next digit is a 3, so we round down. So 3.56 grams is how we should report that answer. Okay. Here's some subtraction. Let's say I had 12.512 grams, and I took away some of that material, and so 2.5 grams I took away. So what does it weigh now? Well, calculator says 10.012 grams. How should I report that? Well, this first measurement went to the thousandths place. It has 3 decimals. The second measurement, though, only went to the tenths place. It only has 1 decimal. So the worst one there, the 1 decimal. So our answer has to be rounded, so it only has 1 decimal, so 0.0, and then the 1 keeps it down, round it down, so we get 10.0 grams. Your turn. Go ahead and pause the video and give these 3 problems a try. Okay, once again, I'm going to punch it all in my calculator and show you my calculator says here for all of these. It's not the point of this. It's, okay, how do I round it? So my calculator says for this first one, 22.85. Well, this one has 2 decimals, and this one has 1 decimal, goes to the tenths. So my answer should go 1 decimal. That's it. So I want 0.8, but how? Oop, there's a 5 there. 5 rounds it up to 0.9. 22.9. Okay. This next one we subtract, and I get 11.212. This one here has 2 decimals, goes to the hundredths. This one has 3, goes to the thousandth. 2 decimals is worse. So I want to round my answer to 2 decimals, 0.21, and that's it. The 2 rounds it down, so just 11.21. This last one here, we got 4 of them we're adding together. This one has 4 decimals, 1, 2, 3, 4. This one's got 1, 2, 3, 4 as well. This one's got 1, 2, 3, 4. This one's got 1, 2, 3, 4, 5 decimals. So of these, but all 3 of these have 4 decimals. Okay, so they're all 4 decimals. This one's 5. So our answer needs to be rounded so that it only has 4 decimals. Right now it has 5. So 1, 2, 3, 4. We need to round it to the 8. The 7 is next, so that means it rounds up to a 9, giving us 0.1809.